Day 6. Security and Access Control. Today we're going to cover a lot of security related topics. We're going to start off with RBAC, Role-Based Access Control, and how it's used to assign permissions to objects within Kubernetes. Then we'll install KeyCloak, an identity and access management server that we're going to use to configure up with our Kubernetes OpenID Connect client and also a user with groups. After that we'll move on to configuring Kubernetes to use KeyCloak's OpenID Connect client, and then we'll secure the Kubernetes dashboard, followed by securing the Kubernetes CLI kubectl. And finally we'll finish up doing some homework. Next video, RBAC. Day 6. RBAC, otherwise known as Role-Based Access Control. RBAC is used in Kubernetes to control access to resources based on roles that are associated with subjects. A role is a set of permissions, and a subject is an entity, such as a person, a group, or a service account. There's extensive documentation on the Kubernetes website about RBAC. If we go to the reference section of the website, and then under accessing the API, have a look at the using RBAC authorization, we'll find a page that has a lot of detail about the types of resource that you can use with RBAC, such as roles and cluster roles, and then the role binding and cluster role bindings, which we're going to discuss in a lot more detail. So there's 4 fundamental resources used within Kubernetes to define the RBAC configuration. The first one is role, which defines a set of permissions that are scoped to a particular namespace. A role cannot grant permissions to cluster resources such as a node, or across more than one namespace. A cluster role, as the name would suggest, is scoped at the cluster scope, and this does allow you to use nodes as a definition. Next is a role binding. So a role binding is a binding of one or more subjects to a role or a cluster role, and this role binding resource is scoped to a particular namespace. And then finally we have cluster role binding. This is a binding of one or more subjects to a cluster role that is scoped at the cluster level. So let's start by having a look at a role resource. Now the difference between this role and a cluster role is that the kind would be cluster role, and the cluster role would not have a namespace defined. Otherwise they're the same. So what we see is that we have a rules spec, and in there we have sets of rules. Each set of rules has a few key fields, such as API groups, resources, and verbs. Additionally, or instead of resources, you could have resource names. So the API groups is something we discussed earlier in the course under the Kubernetes manifest video. And as we said then, if you don't define the resource group name, then it's the core/legacy resource group. So the next field that we see is resources. And then there we see the resources that this particular rule is applying to within the particular API group. So we can see this rule here defines config maps, namespaces, pods and secrets as the resources that we're going to apply some permissions on. So the permissions come under the verbs field. And this is a set of HTTP verbs. So in this rule we can see that we're allowing the get HTTP verb against these resources in this API group. We can see we have additional sets of rules. So in this slide we can see the available verbs, HTTP verbs, that we can use to assign permissions to sets of resources in an API group. So as we saw already, we have the get, and then we have list, watch, create, update, patch and delete. Now not all of these verbs are available if you're using resource names. Okay, so how can we see what cluster roles and roles do we have available in our Kubernetes cluster? Well, that's going to be using the kubectl command. So we'll start with cluster roles. As we can see, there's quite a few of them. Now, out of the box, Kubernetes comes with a collection of cluster roles defined as standard. As we can see here, we have things like admin. There's also a lot of them that are prefixed by system. And obviously those are used by the system itself, and you really wouldn't want to touch those. And the Kubernetes website, once again, has extensive documentation on those default roles and role bindings. So if we have a look there, we can see the types of role, and as I said, a lot of them are prefixed by system. So now let's look at some roles that are available in a namespace. We'll have a look at the roles that are in the kube system namespace. And there we can see that there's a few that are predefined, such as system roles, and at least one that we've installed ourselves when we installed the cluster earlier on. Okay, so once we've got our cluster roles and our roles, they're not really very useful on their own. To make them useful, we need to bind them to a subject. So this is where a role binding or a cluster role binding resource comes into play. In this example of a role binding, we can see that we're assigning permissions to a subject using the role that's been defined called RBAC. And the subject that we're assigning this role, this set of permissions to, is a service account called RBAC that lives in the Rook namespace. So in this slide, we can see the types of subject that we can assign roles or cluster roles to. So first of all, we can assign to a subject of user, which as you would expect is a user, and then group, which is a group of users, and then finally, as we saw in the previous example, a service account, which is a service account resource. Something to note about role bindings is that you can bind a cluster role to a role binding that lives in a namespace, but you can't bind a role to a cluster role binding. This is a useful capability to have, as it allows you to define generic permissions at the cluster scope using a cluster role, and then apply them to subjects in a particular namespace using a role binding. A good example of that is the view cluster role and binding it to subjects in, say, a production namespace. Okay, so let's have a look at what cluster role bindings and role bindings we have. So we'll start with cluster role bindings. And once again, we can see that there's a lot of default system-generated cluster role bindings. And then we'll look at the role bindings in the kube system namespace. And there we go. As we progress through the next videos on day 6, we'll be creating our own roles and role bindings. What we've done in this video is to provide an overview of how RBAC, aka Role-Based Access Control, is implemented in a Kubernetes cluster using role, cluster role, role binding, and cluster role binding resources. In the next video, we will install the KeyCloak Identity and Access Management Server so that we can configure RBAC resources for users and groups in our cluster.